Yeah.
Okay, I
That works
will.
too.
Thanks, Open Office. I totally wanted you to exit presentation mode as soon as you lost focus. Get rid of that. Thank you. Get rid of these again. So, hi, I'm Haun. There would be a bio slide here, but I'm really bad at describing myself, so we just didn't do that. But we are going to talk. We are going to talk about how it's important to have the correct Windows focus when you're trying to present things. But tradition also dictates that we briefly go over what we're going to talk about today. And I told you guys the network booting, talk about network booting, but we're actually going to spend about half of it talking about booting the network, which is a little more mundane than that. Also, not appearing in this talk is this alphabet soup over here. If you know what all of these stand for and you didn't do a whole bunch of research for this, you're old. Congratulations.
I want to learn about Apple's netboot.
So, bootstrapping the network as opposed to bootstrapping the computer from the network helps us answer that problem is what do we do when we have our little workstation and it's on a network it's never been before and it has no idea what it's supposed to do. And we're not going quite back far. We're only in we'll say the late 80s here. So we're away from RARP at this point. So the first thing we say is help. And in the form of what we call a boot P request, which is I booted up, I don't know where I am, help. And hopefully we have a friendly neighborhood server that's listening for that. And in this example, we'll say that it's on our subnet, and it just sends us back a request, so a response. That response contains an address and a whole bunch of other information, but that's basically it. A little bit of data. You also have the option to have it go through a system in the middle called relay, which helps you deal with the whole problem of that first message was broadcast, and if you are on the subnet, you didn't hear it. And the relay doesn't need to keep a list of what address everything is supposed to have. While BootP can dynamically assign addresses, there is some asterisks to it that you might not want to do it. And a lot of that comes down to this. This is all the information that's going in that request. The stuff out here on gray is internal to BootP. It's not particularly useful. But you'll notice this list is pretty darn short. And I've made a point here to indicate that this gateway is not an IP gateway. So it's not moving your traffic. It's only the BootP relay. They call it a gateway in this situation. What don't you see here?
DNS.
We don't see DNS. We don't see a default gateway.
No NTP, or whatever options you want to carry. Right?
Yeah, so you don't see a net mask because CIDR was relevant at that point. But we see something that might look like our salvation down the bottom here with this vendor data field, right? So, it's a vendor data field. You can put whatever you want. If you're writing a client, you can make it do whatever, read whatever you want from here. And you tell whoever's managing your product what to put in there. So you can put your net mask in there. You can put your gateway. Fairly popular for this era was the backup gateway. And everybody's got to know what time it is, and you got to know where that time comes from. And eventually we just wind up with a whole bunch of stuff in here. This is opaque. There is no standard for this data format, at least not yet. The only recommendation there is to tag it at the beginning so you know which format it is. So there is no assumption that the one you prepare for your GPS disciplined clock is going to work for a workstation, is going to work for a workstation from another vendor. They might need entirely different data. A few years later in, I believe, 88, there was a standardized interoperable format for this. That only solves some of the problems we have here. If we go back to our workflow at the beginning, which I'm not going to take us back to because there's far too many animations on the slide, notice what also didn't happen. We have no way to know that the client actually took that address. They might not have taken it. It might have been conflicted. And we have no idea to know when the user is done with that address. So once we've given it to the end device, the image is on the administrator to make sure it's not there before it's used again. So if we proceed a little bit later into 89, we can start talking about DHCP proper. DHCP has a very similar flow, and it actually kind of masquerades a lot like Bootby. We've got the same kind of discovery. We've got a DHCP server, but we'll notice this is not a request. We haven't requested yet. We're just asking the servers where they are. They'll send us back an offer, and we can actually get more than one of those. They might even be for different addresses. And we eventually then select one, and now we make the actual request. And then the server acknowledges our request as well. So that means both us and the server know exactly what's going on. These other two servers that weren't selected know that they didn't win, so they don't have to mark those addresses used. However, in the name of backwards compatibility, we're still here. Bootp's protocol is almost exactly the same as DHCP. In fact, most DHCP servers can handle Bootp clients, and Bootp clients can somewhat work on a DHCP network. All we've done is we just added a little bit on the bottom here. We've added a marker to tell us that we are DHCP and a field for more options. But unlike the options in the vendor data section, they are standards defined. So they can be whatever you'd like. There's options for a fortune server, there's options for a time server, there's options for a log server, and there's a healthy wide range of values for vendor-specific options. Additionally, clients indicate what options they support in their requests. So you don't need to worry about running out of space because there is a hard limit of this, and it's much less than 1 MTU before you simply run out of space. So if you have clients that respect things like the time server or respect things like the time zone, you can send those fields to those clients without wasting the space on the others. So yes, I have gone off and talked about my slides before I got to them. What I'll say stuff is, most importantly for DHCP, the dynamic part comes into its expiration and renewal. In theory, they are optional fields, but pretty much every implementation has them. States how long that lease is valid for. Client will try to renew it traditionally at half of the time of the lease, and if it fails to renew it, the client is supposed to give up the IP address.
It's the typical thing.
It is administrator defined. A typical residential system will be about 5 minutes. You'll see hours, you'll see a day sometimes. You'll sometimes see, like in venues, a minute. So it varies widely by deployment. And since we're talking about Bootp clients and lengths, there are also infinite leases. And you'll run into those both in compatibility with Bootp clients, but you'll also run into that if you actually are only going static.
What hardware do you see today that does Bootp but not DHCP?
HP printers.
Okay. Yeah.
There's not much you see today that does it. One of the notes is that your Bootp program can exit once it does its job. Your DHCP agent has to do this renewal. It has to handle tearing down the IP. It has to run constantly. Okay. We talked about being able to configure the network in a vendor agnostic way. Option and format for the subnet mask is always the same. And we get to know whether or not the client actually took the IP address. If they, crash while trying to parse it, if the power went out the wrong time, and that allows us to maintain a generally accurate database of what address is in use. And clients generally during shutdown, a part we didn't carry in our little animation was that clients will indicate when they are done with an address. So when you shut down pretty much any major network operating system, it releases its address back to the pool, so it can be used again. But we're still, and you can implement new functionality without breaking other clients, because all of these fields are what are called TLV. You've got a type number, you've got a length, and you've got the data. If you don't know the type number, you just skip that length, and then you don't care. You go on to the next option you care about, because servers are allowed to send you options you didn't ask for. And there are a few edge cases where you actually want to do this. But we're still in the late 80s here. So let's move on into the early 90s.
So, quick question.
Yes,
On the DHCP option, so I know about the 50% interval renew, but I thought it was they renew at 50% in case the DHCP server is down at the 100% renewal time. So then they're supposed to try and keep renewing after
yeah,
that.
so if you fail to renew at the 50th time, you keep going until you hit the 100% time. And there's also an extra mechanic that you get the IP address of the DHCP server that gave you the address in response. You're supposed to hit it unicast first. If it doesn't happen, then you broadcast it. Because if you've got, say, multiple DHCP servers working out of the same lease database, they might be aware of each other's leases. But if you start trying to renew at halftime, you keep trying to renew until it's gone.
What would the interval be past halftime?
It is defined by the standard, but I don't remember it off the top. There's like 3 or 4 timer values, and they're all configurable by the server.
I was literally talking about this Sunday night, and I could not remember what.
Yeah, so T1 is half the lease by default. I believe T2 is an 1/8 of the length of T1. And I know some clients go exponential. Not all clients are well behaved in this case,
Okay.
especially if your client works as a 1-minute cron job.
Fair.
So we're now firmly into the 90s here. And let's just say, for the sake of this argument, that you're Intel. And your collaboration with Microsoft in the form of what everyone started calling Wintel at this point has largely taken over the consumer computing market. It's not made a whole lot of inroads into business in the way that it will later, but you have started publishing the system design guides, and they've been wildly successful. And it's become incredibly clear to you at this point that you and Microsoft, to a degree, now control the destiny of the PC compatible market and not Big Blue. The PC system design guides, while you might not be familiar with the documents, you've seen the contents of them. These are the documents that give us the mint and lavender PS2 ports, the green speaker ports, all the color codes for all the ports that we're used to are in here, except USB, it's its own document. Because USB is its own thing. And even baseline standards for what counts as a PC. You know, these have recommended clock rates, these have, peripherals, all kinds of stuff are in these. But we're more down here around PC 98 because this helps us define what a PC physically is, but not really how it interacts with other systems. And I'm getting some side eye over here.
Where's the PC design guide for 2000?
So because they skipped some years, and there actually is a 97 one, but I couldn't find a copy of it because Intel took that down, and I'm still trying to torrent an internet archive of it, but it's really slow. So there is a 97, but they didn't do every year, and at some point the manufacturers kind of started taking the reins over from Intel at that point. Everything that we came to think of an HEX PC somewhere around like PC 2001. That stuff didn't change a whole lot, especially with the prevalence of USB, the peripherals that a computer had and the way they interconnect. USB just got faster and faster and more capable. I'm kind of glossing over FireWire or IEEE 1396, 1394.
Yeah.
But this doesn't talk about how they work in the enterprise. And Wintel machines were originally meant as personal computers. They didn't have anything central about them outside of the CPU in. So if you had, say, I'm going to say the nasty word, a mainframe at your office and a whole lot of terminals, you have one system to administrate and a bunch of peripherals. If you now have every one of your call center agents has a PC, you now have potentially hundreds of systems to administrate, each with their own potentially individual failure domains. So Intel had their own answer to this solution, which they called the wired for management baseline, which you can tell we've got some corporate speak because we're immediately talking about total cost of ownership here. And we're not going to talk about everything that's in this document, but it does introduce a lot of interesting concepts about power saving, about remote management in general. And at this point, the OS was considered a really strong part of this solution. This wasn't done in collaboration with Microsoft, or at least they are not credited. But they do talk a lot about SNMP agents as part of the OS, how DMI interacts with network software. We didn't have an equivalent of IPMI for the desktop at this point, but it's pretty clear that people were thinking that might be possible in the future. Again, literally the first thing we hit here is that is the total cost of ownership. Because it turns out, having people administrate hundreds of workstations kind of sucks. And as you start moving away from just using the PC as a terminal and using it in more computing situations, that gets even worse. And there's a ton of stuff in here, but the one we're going to be talking today about is the pre-boot execution environment. You know, jokingly called Pixie because it comes along, waves its magic wand, and your OS is installed. Or at least that was that was kind of two of the major use cases that Intel was going for. Later in this document, they talk about the primary function of Pixie being to paste the installer program onto the system. And it can definitely be used for that, but it is somewhat of an homage to what came before. One of the things that was on the list of things we aren't talking about today was something called Ripple. And other systems like NCP, well, part of NCP, where the idea wasn't to install a target system. The idea was to run a system without a disk, either to save cost or to find a happy medium between the large system with many terminals and, you know, a full-on independent system. Especially because at this time, disk drives were still quite expensive. You know, BootP came into existence, and we talked about it earlier, because of general annoyances in its predecessor at the time, which also most of the things we don't know about. By the way, that far side was very full of lies. It couldn't cross the subnet. That indication we had with the relay server, there was no equivalent of that in RAR, as well as other details like the subnet mask they gave you. There was no support at all for communicating any of that information. Some vendors had solutions. They were somewhat limited. In kind of back to the Pixie here, Pixie has one, maybe two jobs. The Pixie uses DHCP options that we've seen before. And among those options, even in the very first BootP was a boot server and a boot file name. Pixie doesn't actually use those. It uses DHCP's replacements for them, but its entire job at the end of the day is to download a binary over TFTP and run it. The interesting bits talk about what you can do besides that and what happens when you have multiple. So there's also some other things of note. My speaker notes aren't showing it, so I'm going to do this a little bit more from memory. I should have said that. But additionally, before this, generally, if you had a network boot system, you had hardware-specific and solution-specific software. That might run off of a floppy disk. That might run off of a ROM. You might be expected to burn that ROM yourself and socket it into your network card, which wasn't particularly convenient. And as ATX became more common, integrated network cards became more common, often just wasn't even an option. One of the things that PXE provides is something called the UNDI, the Universal Network Driver Interface. So you as a vendor can write one network boot program for any network card that comes with a BIOS extension for Pixie, or for any motherboard that has it on board anyways. Or even in the case of where you can load one onto a floppy. You also have multiple architecture support. Part of the negotiation of Pixie is the client indicates its architecture from a list. And the server is expected to respond with something for the appropriate architecture. So if you've got your DEC alphas, your NEC PC98s, your Wintels, all on the same network, which I guess you can do that, you don't have the problem of one of them trying to boot the other's firmware. And back to Intel's goal for this whole picture of wired for management is to make systems universally manageable and universally managed. Also coming out of this, while Intel did not invent Wake on LAN, Wake on LAN was a mandatory component of the baseline. So any machine that met that, which meant pretty much any machine sold to a business after about 99, had both Wake on LAN and typically Pixie 2.1. Now, I did promise we were going to talk about the UEFI. Now, not a whole lot really changes with Pixie, because Pixie supports multiple architectures. And as far as Pixie is concerned, UEFI is about 3 more architectures. There are some fun, interesting things in here, because EFI not only supports x86, 64, ARM, Long March. It also supports what it calls boot code. If you've ever worked with open firmware, it's a very similar idea that there's an open firmware virtual machine, just like there's a UEFI boot code virtual machine that can be used to write platform agnostic ROMs. So the same reason that you could pull a graphics card out of a G3 Mac and shove it in a Sun workstation and it just work, and do the opposite with a SCSI controller, in theory can be done with UEFI, but it is generally not implemented. We'll get to that in a moment when we get down to secure boot and as to why that is. But as far as Pixie, secure boot acts as normal. Though because most of us that are doing network for provisioning are doing these on servers that generally don't come with an OS installed, one of the quirks of secure boot is out of the box, it doesn't actually enforce anything. It comes in a mode where it hasn't been provisioned, doesn't enforce anything. They call it, yes, thank you. They call it setup mode. Once you've provisioned a key, it goes into user mode and it starts checking. You can move it between audit and back to user, which disables enforcement. But once it's moved into deployment, it requires human presence to take it back. If you buy a PC that comes with Windows, it comes in that deploy mode. But if you've bought, something from Dell or something from HP that didn't come with an OS on it, it generally does not come configured at all. However, vendors vary, and if it's Lenovo, it's even worse sometimes, because not only do they ship in deploy mode for Windows, regardless, their bootloader at one point checked if your human described title was Windows Boot Manager or Red Hat Enterprise Linux, and if it wasn't one of those strings, it would refuse to boot. Which led to many distros having the ability to lie and say they're Red Hat Enterprise Linux. Also interesting, in addition to the Pixie, UEFI defines an HTTP boot structure, where Pixie is loading a program, there's things to deal with multiple architectures. In most cases, if you're using UEFI, you're almost certainly Wintel. There's an asterisk here now that we're starting to see a lot more ARM stuff come out with UEFI. ARM has a standard they call system ready that is in the vein of like the PC98 standards that's trying to define what is an ARM system and how does it interact with the world. And that includes EFI support. But just like with Pixie and the other parts of DHCP, a server identifies its architecture to the client. Client identifies its architecture to the server at all times. And in HP boot, instead of sending back options, instead of sending a TFTP location or some other things that may be supported, it sends a URL. And the firmware of the server is generally capable of receiving URL of HTTP. HTTPS, a little bit weird. Sometimes there's no cert store. Sometimes it can't check certs. Sometimes it's got to be a publicly trusted cert. Coming back to your talk, most of them will let you at least add a root. Some of them will even let you add a client cert.
And at that point, HTTP is just the way to go.
Yeah, there are a few things that Pixie can do that HTTP boot have, but they're not terribly relevant to most modern applications.
There's also multiple versions of system ready for ARM.
Yes, there are.
Yeah, so like
I think we're on 2.
Raspberry Pi is not UEFI ready.
Yeah, I didn't think the Pi.
Versions are.
I didn't think the Pi was system ready at all. I didn't think they were trying for it.
It might not be.
I've got some Rasda boards that claim system ready, but it's a pain in the butt to get the firmware for them on it.
But the system ready that is UEFI is the most expensive.
Yeah.
Boards you can buy. Yeah.
Yeah. So what's also, to get a little bit of a side with UEFI, as the EFI and eventually UEFI was coming out, everybody was looking at Intel and saying that Intel is going to use this to seize control of the market. And in an attempt to dispel that, whether in truth or only in visuals, Intel open sourced their reference implementation of the EFI BIOS called the EDK now, the Embedded Development Kit. And it is extremely prolific. There are tons of projects where people are porting it to Chromebooks. I've got a bunch of SBCs where folks support it. I've tried my hand, but not yet succeeded at porting it to some boards that run on little Rockchip SoCs. And if you've ever used like an Intel server from maybe about 10 years ago, they have a very distinctive way the UI for their BIOS and setup works. It's the same one you'll see in VirtualBox. Or if you've worked with Cray stuff from about 15 years ago. They all look and feel the same. You know, how you can kind of like how you can tell whether something's running Nginx, judging by how its error pages look, even if they've turned off the server title. Because of that, all kinds of stuff that didn't ship with it technically has it. And amusingly, the kind of tech recycly YouTube scene seems to be noticing this about right now. So we're seeing a whole bunch of content of folks, you know, either compiling or finding pre-built binaries to put the EDK on the Chromebook from 5 years ago that got thrown away. In all kinds of places it wasn't before. So why do we even care about net booting, regardless of all of what EFI gives us? Because there's a lot of neat tricks EFI has that are far out of the scope of what we're targeting for today. Why would you net boot a system? I've alluded to this a little bit today. You may just want to lay down an operating system. Pretty much every major operating system supports this, you know, including ones not pictured here. You know, Foreman's in this bucket because it does a pretty good job of deploying most Linux-based operating systems. But there's other platforms, and they generally all do it through some variant of Pixie. You might just have other business work to do. You know, generally vendors don't recommend laying down images on workstations anymore. You know, Apple has their whole system with DEP, and Microsoft has Intune and Autopilot, where they'd rather you customize the system as it stands as opposed to nuke and pave. Or maybe you just don't trust your system anymore. And now we come to the part where my hubris may really come to bite me.
Tailscale plus
No, the Tailscale doesn't do broadcast.
also saying to get into your house.
Oh no, it's all VMs on here. I'm going to change this. This might, I will need to know if this breaks the share. Oh, well, that's an answer. I will need to reshare. Oh, well, I mean, so far, all we've got is trying to get the Zoom window out of the way of what I'm doing. So we've got a little host-only network here. For the sake of making my life easier, I have a software router on that network that is connected to an interface on my machine. So this is all living inside of a network that doesn't see much. This will take a moment to boot. While this is booting, we have our friendly neighborhood DHCP server. This is just KA DHCPD. This is the ISC's replacement for ISC DHCPD, which has been the standard for a long time. It's generally considered a full-featured DHCP server. It can do active, passive failover. However, this is to illustrate one of the things we didn't talk about in the main content. Your netboot doesn't have to come from your actual DHCP server.
What Linux distro uses OpenRC?
This is Alpine. I've got two Alpine, mainly because I can run Alpine and 256 megs of RAM. There are a few others, though. I think Slacks supports it, and there are definitely others. As I log in with root, shame on me.
There are people who don't want to have root.
Not ready yet.
Oh, come on, don't try to deny it.
When it's my house, I am.
Of course, the router actually has to be up for that to work, so I may simply be impatient. So this is to demonstrate that there's no netboot shenanigans going on in the system at all.
Can you make the text a little bit bigger?
I will make the text bigger. I'm holding the button that makes the text bigger.
Okay.
There, text is bigger.
Beautiful.
And now,
Editor to Nano.
no, we're not even going to use an editor. We don't. We're only reading. So we're going to just kind of bounce down here. The only thing that's configured in here is an interface, the timers that we mentioned earlier, and there's some more timers that are about how the server behaves. And we can see my lifetimes are an hour. Now the client can actually express a preference on time. though the server is not required to respect it. So we're setting a DNS, we're setting a name, and that's it. We're also setting the router and the subnet. There is nothing netboot in here whatsoever. And to wit, we haven't started the proxy DHCP server. So if we take one of our test systems, let's use the classic BIOS one. It's going to try to DHCP. The Pixie client ignores responses that don't include the Pixie client options. So even though Kea is currently sending it responses, it is ignoring them. And it has a standard defined backoff of no seconds, 2, 4, 8, and then 16. And we're going to hit that 16 pretty soon here. We'll see if I've timed my pattern correctly. The answer is no. And it is eventually going to time out. We can also control C it if we don't care. And we'll have the exact same behavior on EFI. However, the UI on the EFI is often a lot more Spartan. And so it'll just, it doesn't give you a spinning indicator, doesn't give you these kinds of like earlier status messages. So now we're going to start up another Altine VM. And this is running DNS mask, which is made famous by the DDWRT and OpenWRT projects. It is a combined DNS, DHCP, TFTP, and a few other things server. And its entire job is to do all the things that a simple home network router can do. It also can be a proxy DHCP server. And if you look carefully, you'll see this machine is a DHCP client. Our DHCP proxy is a DHCP client, and that's totally fine. It just means that I have to type the correct IP address into my SSH here. And the correct username, because this isn't going to work, because OpenSSH won't let you try to change usernames during the login session. Yeah.
Aaron, is this DNS mask VM that the software router you referred to earlier?
No, the software router is running VIOS. It is not running any DHCP at all, because it actually was a latecomer to this instance, because I didn't really want to mirror all of Alpine to be able to do this demonstration. So if we take a look in here, we have a few entries in here, and one of the things that's a little DNS mask-ish is DNS mask does all of its configuration in this key value format. It's actually the exact same command line arguments you would give it. The only thing that's the only thing we're really going to talk about is, first of all, we have a DHCP range, but only kind of. We only have the beginning of it, because DNS mask is not responsible for handing out IPs. And it's running in proxy mode. And I alluded to in the summary that we have some really confusing terminology. If you remember earlier, we had the DHCP server that was forwarding requests, or it was a bootkeeper server. That's not called a proxy. That's called a relay. Proxy is, think of in lieu of. The proxy provides supplemental information only to Pixie clients. It won't respond to anyone else, and it doesn't set an IP. And we can say here that we're going to Pixie. We actually can give multiple options, which is some of the other interesting features that is apparently almost never used anymore. And we'll talk about a little bit of side effects of it not being used that much. Thanks, Zoom. But we're saying for x86 PCs, we'd like to give Void Linux TFTP to this and Void Linux over HTTP. Pixie itself only ever works with TFTP or multicast TFTP. But whatever you send to it, in this case, Pixie Linux, which is a Linux bootloader, can use whatever it wants. And then we have a very similar setup here for EFI. I'm going to make a small modification here, and we're just going to say, we're just going to label these with what they are so that we can see the difference when we actually boot the targets. And as I get off by 1 errors in my editor.
When do that, Nano?
Yes, but I wouldn't be able to press dot if I was using Nano.
So what are the arcs of proxy service here?
They-
x86, comma.
x86 PC, which means PC compatible BIOS, and x86 64 underbar EFI. There is also IA32 EFI, which would be a non-64-bit Wintel system under EFI. They do exist. I have never seen one. There are also reserved architecture values for ARM, and there's a whole system for dealing with sub-architectures. There's actually also an architecture slot reserved for Raspberry Pi NetBoot, because Raspberry Pi NetBoot on the 3 does some really nasty things in that instead of actually parsing the DHCP options, it scans the DHCP option field for the string Raspberry Pi NetBoot. It doesn't matter how you put it in there, but it won't netboot if it doesn't see that. Though honestly, netbooting on Pi 3s is pain and suffering because there are a ton of bugs in the Pi 3 boot ROM, and the Pi 3 Plus fixed most of them. But if you're going to netboot Pis, you're better off going with 4s or buying a whole bunch of really tiny SD cards and putting just the firmware bundle on there. You'll still be able to netboot. It won't write to the card, but you're able to run the not terribly broken version of the boot code. And Pis 2 and earlier don't have netboot. And the numerals for these, x86 PC is 0 and x86 64 is 7. x86 i32 is 6. There is no value for x86 64 because outside the VFI, because in the PC compatible mode, it all comes up like a 386. And by the time, we don't go to 64-bit mode by the time we've got until we've got OS.
These are options you're sending back.
Yeah, so these will get automatically parsed into an option called Pixie Service.
Got it.
And that's just how DNSMask syntax works. And DNSMask will only send them to clients that have this architecture. So if a client with none of those architectures, it won't get any Pixie Service responses. We also have the option to give a prompt and a timeout. But for this case of our example, the timeout makes things a little inconvenient. And the timeout simply says, if the user doesn't do anything, take the first option. So here we are. Our system under test, of course, failed to boot. Now that the proxy DHCP server is running, we get this. Now, if you've seen a machine netboot, you've seen that first part before, especially if it's got an Intel network card. Second part might be new to you. We get status of the machine. It's worth noting, Wired for Management and Pixie by extension require a GUID. You always have a unique identifier, even if your MAC addresses aren't unique, because you've got some of those crappy network cards. And you'll see we list out the client IP, the network mask, because Pixie always supports network masks, even though the network mask is an optional field. Agents are supposed to infer it from the first octet of the address. They do not always. Some of them crash or ignore the response. The DHCP IP is the IP of the server. The proxy IP is the IP of the...
So question on the mask. Are you saying Pixie is still classful?
Pixie falls back to classful behavior. So if the Pixie server does not provide a net mask, it will choose a net mask that is the same as if it were classful. Now, this menu is those two options that we specified earlier. The reason that we don't generally use TFTP after the first response, especially now that 100 megabyte initial RAM disks are a thing, is because TFTP is kind of slow. That's my question. So we're doing a little healthy on time, so we can suffer through this together. So we downloaded from the boot server, which didn't actually have to be the same server as the proxy. And it has downloaded the kernel. It is now downloading the initial RAM disk. It also doesn't help that current desktop virtualization for anything that's not in 64-bit mode is really, really slow. This may be a little bit.
Transfers over UDP are fine as long as you don't have any losses.
And it's not just that it's losses, it is block at a time, acknowledge the block, and the blocks are small. No, there's nothing like fast start. So even TCP slow start is an order of magnitude faster than what TFTP can do. TFTP exists because it's trivial. It is easy to implement a TFTP client. There's no way to list a file. You want to know if a file's there, try to get it. If you get an error, it's not there.
So if it's a 2 gigabyte file.
Yeah, you might be waiting a while. When we were talking about the universal network driver, it also provides UDP support. It has no support for TCP. It also provides TFTP as, oh, look, it's a kernel. It also provides support as a first-class citizen for getting more files over TFTP. Yep, that is, so one of the quirks of the Pixie is the DHCP response that you get from the server is cached in RAM and available to later stages. You'll notice that if you've ever used iPixie will do a second PXE exchange in most configurations. It doesn't use the cache protocol. Pixie Linux doesn't. So that DHCP response that the boot agent got, it was sitting in RAM and Pixie Linux used it. This is not really an error as far as DHCP is concerned. This is going to sit here for a while just because the way that this particular system is set up.
Is that the reuse of the IP similar to iSCSI boot, where it looks at a specific address space and it knows?
It's kind of like that. It's similar to the IBFT, but not quite the same.
Yeah.
There we go. Oh, my hubris has got me. So you remember how I said it doesn't matter if the proxy is a DHCP client? Well, it turns out that's only true if you didn't put the IP address anywhere. And we did. So we're gonna fix the HTTP one, because in my infinite hubris, there's an IP address here. And now there's not. And we're not netbooting Alpine because turns out Alpine's support for TFTP route, for NFS routes appears to be just broken. So by the power of editing a text file and pressing Control-Delete, and we're going to do this next boot with HTTP because we'd rather not wait through that again. It is significantly faster. Of course, now that I talk about it, it's going to be shy, but we're already done through the kernel. Yeah.
Much faster.
That's a tremendous
Yeah,
difference.
and if you've played around with the with some of like the modern retro computing, you might have seen the LWIP stack, which works on a massive amount of older network cards. Pixie Linux actually now has that integrated, and that's how it does its HTTP.
So what was the option? It was mod boot? I haven't seen that option.
Which one?
It's like mod boot.
Oh, mod loop. That's an Alpine specific thing. So I was trying to get Alpine going earlier. We're actually booting Void. We're not booting Alpine, but mod loop is part of how Alpine handles kernel modules. Instead of storing them all in the initial RAM disk or storing them, even on disk, it stores them in a file that gets loop mounted, and that file might be being streamed from some other service. So that's an Alpine specific thing. This entry is from here where I was trying to get Alpine booting over this. But I'm not going to commit to say that I believe there is an error in the way their module system handles NFS booting, but I believe there may be one. Yes.
I guess Alpine doesn't use Draycut. Does Void Linux use Draycut?
Void does use Draycut.
Yeah.
And so you'll see there's a few Draycut style arguments in here, party lux, and all that in here. Though this root NFS : style is used by many different inits, including the init in Alpine. It actually does try to mount the NFS root. I'm only using the kernel syntax here as I was trying to troubleshoot it, but it's not actually bringing up the network interface. And it's likely that there is some argument it wants that's not documented.
In the DHCP response?
No, because it never even brings the link up.
Oh, okay.
So it might be the equivalent of, say, Draycut's rd.neednet.
Yeah.
But I have most of my experience with initramfs tools and with Draycut. And so Alpine's system is somewhat of its own. So, and in this case, we have a system that I have just typed control characters into. And unfortunately, I cannot make this bigger. I also can't type the right password. I had hoped to be able to make it play Doom for you today, but unfortunately, SDL, VMware, they don't go together, and I couldn't get a functional X server on here in time. So we can quote unquote play Doom in that I can start the binary and it will actually run if I can type. There is serious lag on this. Like it prints the banner, it tells us what, oh, actually, no, it doesn't. So in the past, it was telling me that it was loading the level and it was playing the music. So we ran Doom, it just didn't work.
You did try.
I did try. So I'm going to go correct this same error in a different bit of our demo space here. I wish it were, my friend. I wish it were. I guess it's kind of interesting because, by the time all of my experience with Doom was just trying to get to run on things that
Just had to make sure the floppy was inserted correctly.
So I saw something on YouTube. You can run Doom on one of those Apple Thunderbolt to HDMI adapters.
So we talked about how the boot menus in EFI aren't used correctly. The VMware BIOS, which I'm not sure what it is because this is not EDK. It doesn't look like EDK. Well, actually, it calls it the boot maintenance manager, so it might actually be EDK just skinned up a little bit. Its first attempt to boot from the network doesn't work if you have menu entries, but if you tell it to then boot from the network after failing, you get a perfectly functional EFI. These are actually loading the same kernel initial RAM disk. They are using different versions of Pixie Linux. This is using Pixie Linux for, EFI. We're running in full EFI. We're already in 64-bit mode. And you might notice that the frame buffer looks a little different. VMware's EFI frame buffer looks a lot like their BIOS one, but some vendors have even different fonts or for some reason have obnoxiously slow scrolling. And both of these systems are booted off the same kernel and RAM disk and are running off the same read-only NFS map. Because I wanted to not run my workstation out of memory by dragging a copy of it around. Do we have any questions about the lab setup or why I would do this craziness?
Does everything support V6?
In theory, yes.
Something to be determined.
What's
So
your next talk, Daniel?
Kea, yeah. So Kea does support V6. PXE Linux supports V6. At least kernel supports V6. Pretty sure VMware supports V6, and the thing I'm using as an edge router does. So there is no reason this couldn't be done in V6. It's just that I have to hand key the initial IP addresses into the machine's video terminals, and it's probably hard to get an idea of just how laggy this is. The VMware UI has apparently gotten really bad over the past few years, and I haven't bothered to find another desktop virtualization system on Windows, but I wasn't about to try to do a Zoom share on Linux, on KDE, on Wayland.
So here's a weird question. Why are you running BIOS?
Because I'm familiar with it, that I can get a functional NAT router up in about a minute and a half.
Okay.
I started with Juniper, so its CLI is very, very similar to Juniper.
So if you want to go ancient and easy, look at Shorewall.
Isn't Shorewall discontinued?
So,
Shorewall ported to no.
Or it loves running Windows XP still.
Yeah, but we have a little corner for that.
So
Shorewall
Shorewall ported off the monowall, and then pfSense ported off the Shorewall.
Yeah.
And then now OpenSense is ported off of pfSense.
The other thing is,
Yeah.
I like CLI style stuff, and the CLI that's in
Wow.
yeah, the CLI that's in OpenSense just sucks.
It wasn't CLI first, right?
No, it wasn't.
pfSense was the GUI first, PHP application first, right? And then they kind of ported it on.
You can terraform your OpenSense instance, but
I'm sure you can.
I just did it.
Yeah.
Yeah, it's like-
I also had to reinstall it like 6 times, so the Terraform really helped.
Yeah, but BIOS is kind of like iOS-ish, right? No,
It's much more Junos
Exactly what I'm
like.
missing. Why are you using bugs?
It's much more Junos
It's
like.
more Nexus like.
It doesn't feel like
You're gonna be Aaron's personal
Yeah.
network engineer?
So I started with Juniper, then VIOS, and then I picked up something that has a clone of iOS, and I was like completely useless. Because I was so used to, so, you know how in iOS you go like interface and you're in a mode.
Yeah.
Junos doesn't have modes per se, it has a tree that you move around. So like if I go, edit interfaces, edit Ethernet, ENFO, I'm now, all my commands are at this position in the tree. And there's relatively few commands. So and no commands are immediate.
Which iOS does that too, right? That's iOS is kind of.
Yeah.
Kind of.
Yes,
You do, it has that.
you go into the same kind of
Yeah.
structure, yeah.
But the thing is, you don't, until you commit it though, right?
Yeah.
It's the same thing in BIOS,
Yes.
right? You commit, yeah.
Yeah.
For sure.
So does Junos have commit? Sorry, does iOS have commit now?
It is not.
Does not
It's
yet.
not. So there's-
Because
that's different.
I didn't know about the reload in technique until you mentioned it.
Yeah.
Because
That's the walk of shame.
So
You
when
don't
you
ever
run
want to do that.
shut, it's immediate.
It's immediate.
Oh, okay.
yeah, Aristas apparently can do transactions. So like I have, we go show compare. We can see that I'm removing DHCP from an interface. What I could do is in Junos it would be commit confirmed, but in VIOS it's commit dash confirmed. And basically starts a timer. Once the commit's applied, 10 minutes. If you don't tell it you're happy with it, it goes away.
That's a very much a Juniper thing.
Yeah. Juniper's rollbacks are a lot more graceful. They don't require the system to reboot. And VIOS doesn't as much now. There are enough syntactic differences between, now if I go rollback soft 1. So now we can see that puts my DHCP back and I can commit what was my previous state.
How many snapshots does it keep?
Configurable, but I think it's 100 by default.
Okay.
And then one of the big differences between BIOS, the Junos and BIOS, is you have to explicitly save in BIOS. Junos, every commit is a save.
I will say I've seen multi-million-dollar customers run BIOS in production.
Absolutely.
I mean,
Yeah.
I'm able to route wire speed on 20 gig on a 30-watt T-core. The only reason that T-core is running MikroTik router OS right now is because BIOS did this DOS stream thing, and I was already having to compile my own kernel for network card drivers because I'm using an old SolarFlare card because SolarFlare cards are really cheap on eBay, and I couldn't manage to use the source bundle they gave to get a functional system, so I just threw my hands up, threw money at MikroTik because their Linux-based router distribution has that network card in, is a one-time purchase forever, and while they strike the balance of having a good enough GUI that it's worth using the GUI sometimes, but the CLI is also pretty good. Also because I had the ISO downloaded and I was on slow internet.
Yeah.
Wasn't it you who told me that a lot of the books that were all the bells and whistles that were in Viata ultimately made it into the kernel?
Pretty much. There's like 3 exceptions. There's Intel Quick Assist, I think it's called, is a kernel extension, and there's a few other similar ones that BIOS compiles in. But most of the DPDK, all the fast tricks like FRR are pretty much, if they're not in the kernel, they're readily available outside of Viata.
What is QAT for routing?
QAT is hardware offloaded. It's not just the checksum. It's not just the checksums. It can do some protocols entirely. It's meant for making little wimpy machines feel less wimpy, and it does a pretty good job of it. And I think it can do accelerated bridging. I'd have to check on that one.
Anybody's actually ported BIOS to run on FPGA.
Do you know?
That'd be interesting.
Now, what did NVIDIA buy, the switching company?
No,
They
no.
lost.
Yeah, they bought Mellanox.
No, not Mellanox, the White Box.
Oh, Cumulus.
Cumulus, isn't that what Cumulus did? They have FPGA?
They had,
Ethernet?
I don't think so, but they had full on PCs in some of their switches.
Yeah, but they weren't doing routing through
No.
the PC,
No.
they were doing it through an ASIC.
Yeah, they had an API to the ASICs.
Yeah.
There's a kernel API, there's a kernel driver class that lets you manipulate a switch chip as if it were a bridge. So you create a bridge, you set up VLANs on that bridge as if it were a Linux software bridge. And those rules take effect on a real switch chip.
This was the WRT54G, the first one.
WRT54G was one of the first well-known implementations. Realtek makes private modules for it, but they only make them available to their subscribers, and Realtek plays the game of it's a module, therefore it's not GPL2, yada yada. Ben is staring at me and is probably going to tell me that I am out of time.
He's on booze.
Oh,
Yes.
Is it about that time? Is it?
it is about that time. I was going to solicit questions, but we've had plenty of good questions through. So, and now I'm not on where I wanted to be in the slides.
We can do questions bar.
Yeah.
That's right.
So, questions at the bar?
No, it's the wing place that also serves alcohol.
Yeah. I'm
They're
not gonna
probably
say-
wondering where are the geeks that drink?
Yeah, I know. They're waiting on us over there, aren't they?
The geeks that drink.
Yeah,
Isn't that a trivia league?
that's us.
It also is that too.
Yeah.
This is the worst day to stop drinking.
Fun fact on Run It, if the power off doesn't work, just run power off 3 times and it does work.
Last one.
Very good presentation, Aaron.
Yeah,
Yes, thank you.
Aaron, thank you very much. Well, thank you. Yes,
We did have
And-
one other announcement.
yeah, we did what?
We wanted to see if anyone was interested in presenting. We're looking for speakers.
Yes.
We're trying to fill up the slots for the next couple of months. So if you have any ideas.
Oh,
Yeah.
If you
All
want to
those
present
who are-
or something you want to see, please let us know.
so if you want to see what happens when you actually turn off the NFS server, so your system 2 file system before you power it off. Because you're not,
Absolutely. Yeah, I think we have openings. I mean, I think next month, actually, we have an opening, right? I mean, if anybody wants to do October,
Yeah.
what's that?
Come on, let's do it again.
So anyway, excellent. Thank you guys very much. Make sure, hey, help me police up the area and everything. Make sure everything is thrown away. We're going to head across over to Tommy Trent's, hang out with us. And an incentive for anyone who wants to present in the future